Dear students, in this lecture I am going to discuss ZPF method of voltage regulation for an alternator. This method is also known as Potier triangle method. The statement of the problem is a 6-pole 440 volt 50 Hz 3-phase star connected alternator has a resistance of 0.15 ohm per phase. The data for open circuit test and zero power factor test are given as follows. For open circuit test, we have field current as 2, 4, 6 and corresponding open circuit voltages as this. Similarly, for ZPF test, corresponding to these field currents, we have terminal voltage as this. Find the voltage regulation of the alternator using ZPF method for a load current of 40 ampere at 0.8 power factor lagging. So we have to evaluate the voltage regulation using ZPF method, also known as Potier triangle method. Make one correction in previous lecture. By mistake, there I wrote ZPFC method. Basically, ZPFC is zero power factor characteristic. So ZPF method, instead of ZPFC method, just make this correction in your notebook, ZPF method or Potier triangle method. Fine. So the voltage rating of this alternator is 440 volt. Obviously we know that line voltage. This is star connected, so phase voltage will be different from line voltage. We need to divide this line voltage by √3 in order to get phase voltage. Also, if not mentioned in the problem, then by default the voltage ratings are line voltage ratings. Unless stated in the problem, we will take these voltage ratings as line voltage. So our first job will be to convert these voltages into phase voltage from line voltage, as this connection is a star. Fine. If delta, then no need to convert. We know that for delta, phase voltage is equal to line voltage. But for this star connected alternator, we may write here Vp like that, or V phase. So convert it, divide it by √3, all values, and write it. Similarly, for this also we need to write corresponding phase voltages. Now the line voltages have been converted into corresponding phase voltages by dividing by √3. So for open circuit test, we are getting the values of phase voltages readings as this, red colored. Similarly, for ZPF test, we are getting the values of terminal voltages as this, phase. Now what next? We have the data corresponding to open circuit test and ZPF test. So we have drawn the corresponding characteristics. So this will give our OCC, open circuit characteristic, corresponding to these readings. I will suggest you to plot these graphs on graph paper to get the values more accurate. So I have roughly drawn the graph corresponding to these readings. That may not be much accurate, but here we are focusing on the steps, procedure. Once you will use graph paper, you will get more accurate results. So we have drawn OCC using this data of field and terminal voltage like this. This is air gap line. Corresponding to this data, ZPF test, we have drawn zero power factor characteristic. This reading is the critical reading of ZPF test. When we are getting terminal voltage as 0. 0 terminal voltage means terminals are short circuited. So in order to get this reading, we need to short circuit the armature terminals and adjust the field current to get rated armature current. So this critical reading indicates that 7 ampere field current is required to get rated armature current when a purely inductive load, here whether loads are connected or not, once armature are short circuited. So once armatures are short circuited, that is corresponding to short circuit test, we are getting field current as 7 to get rated armature current. So this reading will be obtained by short circuiting the armature terminals and adjusting field current to get armature current at its rated value. For other readings, we know that, already discussed that, a purely inductive load is connected and armature current is maintained at its rated value. So for each changed load, field currents are adjusted to get the rated armature current, and corresponding readings have been noted down. If you are not aware of ZPF test, just watch the previous lecture, then come to the numerical section. Next, corresponding to rated voltage. So this is line voltage. So once we will divide this 440 by root 3, we are getting rated voltage as 254.04. So hence, corresponding to rated voltage, terminal voltage, we will draw a horizontal line. Suppose this horizontal line meets the ZPFC at point B. So what is the next step discussed in the previous lecture? From B, we will cut BC equal to OA. Once C point is obtained, and we know that this is 7 ampere, right here, corresponding to this critical point, field current is 7. So roughly I have denoted this. Length of BC is 7 ampere on this scale. So once C point is obtained, parallel to air gap line, we have drawn a line segment which meets OCC at point D. Next, we have drawn a perpendicular from D on this. Let it meets at point E. This is E point, and this is BED is our Potier triangle, in which this BE gives the value of IAR. Fine. Roughly I have taken on this scale, let us take this as 6.2 ampere. Fine. And this DE, perpendicular of this right angle triangle, Potier triangle, gives the value of IAXL. So roughly, let us say this point is corresponding to this 300 and this is corresponding to 254.04, whatever. So roughly this is coming out to be 46 volt. Take these values for calculation purpose. Once these values are obtained, then our next step will be to get the value of ER. So I am going to omitting this, just note down the values. Armature current is 40 ampere, I am writing here. IA is 40 ampere and power factor is 0.8 lagging. So here for lagging we have to evaluate if we will understand the procedure for lagging. So using the formula for leading just or unity, we can repeat the same procedure for respective power factors. Fine. So we have evaluated phase voltage, rated phase voltage as 440 upon root 3, which is 254.04 volt. Now from the formula of ER discussed in the previous lecture, for this lagging power factor we have plus sign here and for leading we have minus sign here. Just check your notebooks, right? So for that lagging power factor asked in the problem, we have used that formula of ER as V cos theta plus IA RA square whole square plus V sin theta plus IXL whole square. Substitute the corresponding values. This is phase voltage 254.04 into cos theta power factor is 0.8 plus sign here, rated armature current is 40 ampere substitute here, and RA in the problem it was given as 0.15 ohm per phase, right, whole square, plus V sin theta. If cos theta is 0.8, then sin theta will be under root 1 minus 0.8 square, that is 0.6. This plus IXL. This drop is IXL, right, DE. So directly we can substitute this. We have taken as 46. So we have substituted this 46 here. So after solving, we are getting ER, magnitude of ER as a square root of this, which is coming out to be 288.36. So from OCC corresponding to this value of ER, let us represent this point as 288.36. Corresponding to this, let us take the corresponding IR as 9. So we have taken, assume that this IR is coming out to be from this OCC corresponding to this as 9 ampere. So whatever it is coming out to be, take the exact value if you have plotted using graph paper. So it will be nearby this, or maybe exactly this, just check it. Now we need to evaluate delta R. What is delta R? If you are not aware of this, then first watch the previous lecture. I am reminding you again and again. So using that formula for lagging power factor, check the signs for lagging and leading. We are getting delta R as 6.61 degree, and for 0.8 power factor we are getting power factor angle as cos inverse 0.8, that is 36.87 degree. So using the formula of IF0, main field excitation current, as this IF0 is under root this, so this square will be this, and after substituting the corresponding values, now we know IR, we have taken as 9, we know IAR is BE, and BE is nothing but 6.2, so we are using 6.2 here. Now we know delta R, just evaluated as 6.61 degree, and we have the value of theta as well, 36.87, right. If the power factor will be leading, just check this sign, this will be changed to positive, right. We have derived these formulas in previous lectures. So from here we are getting field current of roughly 14 ampere, 14.01 ampere. Now corresponding to 14.01 ampere, we have to take the corresponding reading of EF. So from OCC, let us take this line cuts this EF at 341.8. So we have taken 340 roughly here, right, as EF. So whatever it is coming out to be, now we need to substitute this EF in the formula of voltage regulation. These all calculations were performed just to calculate this EF, which is coming out to be 341.8. So after substituting this EF, this is rated terminal voltage, that is 254.04. We are getting our voltage regulation for this load current of 40 ampere at 0.8 power factor lagging as 34.55%. Thank you very much. Hope you have understood the steps used in ZPF method of voltage regulation, also known as Potier triangle method. We have taken certain power factor lagging. Now yourself you may repeat the same procedure for leading power factor for the same data, and you can check the sign here whether it is coming out to be negative or not. Fine. Use the formula of ER, delta R and IF corresponding to that particular power factor stated in the problem. It may further be observed that for evaluating voltage regulation of an alternator using Potier triangle method, ZPF method, we need only 2 points on ZPFC. Point A, mark here, and point B. Fine. So if this point is given directly in the problem, this point corresponds to the rated terminal voltage, and if this point is given means the rated terminal voltage and corresponding field current under ZPF test is given. If you will mark this field current, let us take any field current, right? IB, IFB, I am marking here IFB. So if this data is given, this point is given, and obviously this point is also given, then no need to plot ZPFC accurately. No, these readings may not be required, as this information will help us in obtaining these points by taking this length OA as BC and so on. Fine. So in problems, either these 2 points will be given directly. If this point is not given directly, then the other observed readings will be given corresponding to ZPF test, and then we need to plot this ZPFC, and corresponding to this rated voltage we need to mark this point B. Hope this is clear to you. Fine. Thank you very much.